Right now, somewhere along a stretch of ranch land where the United States meets Mexico, an animal small enough to fit in your palm is preparing to bring down a creature many thousands of times its own weight, and it will do it without a single ounce of force. By the time this video ends, you will understand exactly how a flying mammal barely the size of a mouse has become one of the most economically destructive predators in the Western Hemisphere, why the United States government has spent years building scientific models just to track its advance, and why wildlife agencies along the Texas border are treating its arrival not as a possibility, but as a matter of time. This is the story of the common vampire bat and the full-grown cattle it silently, methodically, and repeatedly defeats. If predators that win through precision instead of power fascinate you, subscribe now and drop a like, because this channel exists to show you exactly how nature's smallest players outmaneuver its giants. The common vampire bat, known scientifically as Desmodus rotundus, is one of only 3 bat species on the entire planet that survives exclusively on blood, a feeding strategy called hematophagy that makes it almost unique among the roughly 1,400 bat species found on Earth. Most bats chase insects through open air, using echolocation to intercept moving prey mid-flight. The vampire bat does something far stranger. It lands near its target and walks toward it, using powerful thumbs and forearms that let it move across the ground with an unsettling, almost spider-like gait, a locomotion pattern found in no other bat species. This ground movement exists for one reason: precision. A vampire bat does not want to strike an animal randomly. It wants to select the exact location on the body where blood vessels sit closest to the skin. And to do that, it relies on specialized thermoreceptors in its nose, structures so sensitive they can detect subtle heat signatures radiating from beneath an animal's fur, essentially allowing the bat to see blood flow the way infrared cameras do. Once it identifies the ideal spot, usually near the neck, the base of the tail, the heel, or the soft skin behind an ear, it opens a shallow wound with teeth so sharp the animal often does not wake up during the process. What happens next is the reason this animal has fascinated biologists for decades. The bat does not suck blood the way popular culture imagines. It laps it, tongue moving in rapid strokes, drawing blood out as it flows freely from the wound. That continuous flow only happens because vampire bat saliva contains a powerful anticoagulant compound, one so effective at preventing blood from clotting that medical researchers isolated and named it Draculin, and have spent years studying its potential use in treating human stroke patients. A single bat only needs about 2 tablespoons of blood to survive through the night, an amount so small that if this were a one-time event, no rancher would ever notice or care. The real danger is repetition, night after night, across the same herd, sometimes for weeks or months at a time. Because vampire bats are highly social animals that live in colonies ranging from a handful of individuals to several thousand, and they consistently return to the same reliable food sources once discovered. That social structure is part of what makes the species so resilient, and it behaves in ways almost unheard of elsewhere in the animal kingdom. Feeding is not guaranteed every night. Roughly 1 in 3 adult bats fails to find a blood meal on any given evening, and because these animals cannot survive more than about 70 hours without feeding before starving to death, colonies have evolved an extraordinary survival mechanism. Successful bats will regurgitate a portion of the blood they collected and share it directly with colony members who came back empty, one of the clearest documented examples of reciprocal altruism in the natural world. This is not random generosity. Bats track which individuals have shared with them in the past and are far more likely to reciprocate with those specific partners, effectively running a social credit system built entirely around blood, which allows even bats that struggle to feed independently to be sustained by the group, letting populations persist and expand even in marginal or newly colonized territory. The vampire bat's body reflects millions of years of evolutionary refinement around this single, highly specialized diet, and few mammals on Earth have adapted so completely to one food source. Because blood is almost entirely liquid, low in fat, and extremely high in protein, vampire bats evolved a digestive and excretory system built for speed rather than storage. Within roughly 2 minutes of beginning to feed, a vampire bat's kidneys start extracting and excreting excess water from the blood meal, allowing the animal to offload weight almost immediately so it can still fly home. Their teeth reflect the same specialization. Unlike most bats, which retain grinding molars suited to crushing insects or fruit, vampire bats have reduced, blade-like molars, since their diet requires no chewing at all, only a single precise incision followed by continuous lapping. That same unusual thumb structure driving its ground movement is so distinct from every other bat species that early naturalists initially struggled to classify the animal correctly within the bat family at all. Despite the horror movie reputation the name vampire carries, documented attacks on humans are relatively uncommon. The real threat this species poses is aimed almost entirely at livestock. That danger is real, and it becomes clear once you look at what happens to a herd over time, because a single bite is almost never what kills a cow. Blood loss from one feeding is negligible for an animal that size. It is the accumulation across dozens or hundreds of repeated bites, spread across an entire colony feeding on the same herd, that produces measurable anemia, stunts calves, reduces milk production, and leaves adult cattle visibly weakened during seasons when body condition directly determines a rancher's income. Open wounds left by feeding bats also become entry points for secondary bacterial infections. But the single greatest danger vampire bats pose to livestock has nothing to do with blood volume at all. It is rabies. Vampire bats are the primary wildlife vector for a specific paralytic strain of this disease across Latin America, and a single infected individual, feeding across multiple animals in one herd over consecutive nights, can seed an outbreak capable of killing dozens of cattle before a rancher or veterinarian even identifies the cause, since early symptoms in livestock are often mistaken for other illnesses. In Mexico, where vampire bat populations are well established, this combination of blood loss, infection, and disease costs livestock producers an estimated $47 million every single year, a staggering figure for an animal most people picture as nothing more than a horror movie prop. That economic reality is exactly why what is happening along the Texas border right now deserves serious attention, because the same species responsible for those losses in Mexico is no longer staying in Mexico. For years, researchers with the United States Department of Agriculture's Wildlife Services Division have tracked the vampire bat's range as it steadily pushes northward, and the driving force behind that shift is climate change. Vampire bats are highly sensitive to cold, historically confined to tropical and subtropical regions where winter temperatures never dropped low enough to threaten their survival. As average winter temperatures across northern Mexico have gradually risen, the northern boundary of suitable habitat has crept upward along with them, opening territory that was previously too cold for the species to occupy year-round. To measure exactly how far this expansion could go, USDA geneticist Dr. Tony Piaggio partnered with United States Geological Survey scientist Dr. Mark Hayes, layering more than 7,000 documented sightings across northern Mexico against detailed climate variables and running 5 independently constructed statistical models designed to cross-validate each other rather than relying on a single method. When multiple independent models converge on the same outcome, it substantially strengthens confidence in the result, and projecting forward through the year 2070, all 5 pointed to the same 2 entry points, the southern tip of Texas and parts of Florida. That is not a distant hypothetical border. Vampire bats have already been confirmed within roughly 200 kilometers of Texas soil, with documented rabies cases in bats recorded in the Mexican state of Nuevo León, in areas that sit farther north than the 3 southernmost counties of Texas itself. Wildlife officials monitoring this corridor have stated plainly that the population is actively moving in this direction, and that it would not be surprising if individual bats have already crossed into Texas undetected, simply because the absence of a confirmed sighting does not mean the absence of the animal. Vampire bats are nocturnal, cryptic, and roost in caves, hollow trees, and abandoned structures during daylight hours, making them extraordinarily difficult to detect even when researchers are actively looking. What makes this expansion especially concerning is the landscape waiting on the other side of that border. Southern Texas is home to some of the highest cattle densities in the entire United States, offering exactly the kind of abundant, concentrated food source that allowed vampire bat populations to thrive in northeastern Mexico in the first place. This would not be the first time a species crossed from Mexico into Texas after years of scientific warning. Africanized honeybees spent decades expanding through Central America and Mexico under close observation before finally crossing into southern Texas in 1990. And their spread across the southern United States moved faster than researchers had predicted. Fire ants followed the same pattern decades earlier, entering through a port in Alabama and expanding across the southeast before effective control measures existed. In both cases, the true scale of establishment only became clear after the species had already arrived, which is why current surveillance treats the Texas border less like a hard barrier and more like a monitoring line. Florida represents a second flank of this expansion that receives far less public attention, despite being identified by the same models as suitable future habitat. Unlike the overland route vampire bats would need to travel to reach Texas, a Florida population would most likely arrive through a different pathway entirely, either a slow expansion around the Gulf of Mexico over many decades, or a far faster route via unintentional transport, since vampire bats are known to occasionally roost inside cargo containers, vehicles, and shipping structures in Latin America. Given the volume of agricultural and commercial trade moving between Florida and countries where vampire bat populations are already established, officials have not ruled out an isolated bat turning up outside its natural range well before any organic northward expansion ever reaches the state. Complicating the detection effort even further, cattle are not the only large mammal this predator relies on, and understanding its broader diet explains why border monitoring alone may not be enough. Before cattle ranching existed on this continent, vampire bats survived for millions of years feeding on native wildlife, including tapirs, peccaries, deer, and large ground-dwelling birds. In more recent decades, the species has also adapted to feed on feral pigs, an invasive species already widespread throughout Texas, which means a viable food source for an expanding vampire bat population exists well north of the current border, independent of cattle ranching entirely. That matters enormously, because it suggests a colony would not necessarily need an established herd to survive an initial foothold. Feral hogs alone could sustain a small population long enough for it to grow before ever targeting livestock directly. None of this leaves ranchers without a way to respond, though, which is precisely why USDA field teams have already increased surveillance across the region, physically inspecting livestock at auctions, feedlots, and ranches throughout southern Texas for a very specific and recognizable warning sign. A vampire bat bite leaves a small, distinctive wound, often crescent or teardrop-shaped, typically found behind the ears, along the neck, at the base of the tail, or around the heel, frequently accompanied by a visible trail of dried blood running down the animal's side, where the wound continued seeping after the bat had already left. Ranchers who spot an animal with an unexplained wound in one of these unusual locations are now asked to report it directly to Wildlife Services, since a single confirmed case could represent the first hard evidence of an established population north of the border. And once that evidence exists, the region is not starting from zero. Vaccination programs targeting cattle against the specific rabies strain carried by vampire bats have proven effective at reducing livestock deaths in regions where the species is already established, though they do nothing to prevent the underlying blood loss and stress caused by repeated feeding. Physical exclusion, sealing known roosting sites in barns, caves, or abandoned buildings can reduce local activity, but requires finding roosts that are often hidden and hard to access. Some regions have even experimented with applying anticoagulant gels to captured bats before releasing them, exploiting the colony's own social grooming behavior to spread a controlled dose through the group. What every one of these strategies shares is a dependence on early detection. A region that identifies activity before a colony becomes fully established has dramatically more options and dramatically lower costs than one that discovers the problem only after the population has already taken hold. A common vampire bat weighs somewhere between 25 and 40 grams, while a full-grown ox or adult beef cattle typically weighs between 600 and 900 kilograms, a size differential of roughly 20 to 30,000 times. It does not need to overpower its prey, because it was never trying to kill in a single encounter in the first place. Evolution shaped this animal around stealth, precision, and repetition rather than force, producing a predator capable of returning to the exact same target night after night, extracting just enough to survive while leaving the host alive to be fed on again. A strategy that let this species thrive across an entire continent for millions of years before humans ever introduced cattle into its range. The vampire bat is not moving into Texas because it developed some new aggressive behavior. It's moving because warming winters finally let it survive somewhere it couldn't survive before. And unlike most range shifts driven by climate change, this one comes with a direct price tag attached to an entire regional cattle industry. Ranchers, veterinarians, and government scientists monitoring that border are no longer debating whether vampire bats will establish themselves inside the United States. Based on a decade of converging data, the question is simply when and how much of southern Texas's cattle industry will be within reach when that day arrives. If this changed the way you think about how a predator's true power has nothing to do with its size, subscribe to this channel, because every week we break down real predator and prey battles from across the Americas, showing exactly how the smallest and least expected animals repeatedly overpower creatures many times their weight, using nothing but biology refined over millions of years of evolution. Turn on notifications so you never miss the next confrontation nature has been quietly running for far longer than we ever noticed.